Welcome students. Just continuing the class after this mass spectrometry. This is NMR spectroscopy, in which we are how this NMR spectroscopy is applicable to characterization of isolated natural compounds. So how this instrument, so sometimes this is also same like we need to know about the basic principle behind NMR spectroscopy and its application towards the natural isolated compound of characterization, what type of structural elucidation can be performed, was we are making into short. I'm just discussing. We cannot discuss the complete details like in analysis or analytical chemistry or instrumental analysis, but still it's needed for you to write about what is NMR spectroscopy and how it works and what is the spectrum which is available, how it is applicable to herbal formulations or herbs, natural compounds in characterization of isolated compounds. So NMR means actually nuclear magnetic resonance. So NMR spectroscopy is a study of spin change at the nuclear level when radio frequency energy is absorbed in the presence of magnetic field. So when you are applying a magnetic field and that magnetic field, that radio frequency energy level of the nuclear energy absorbs and it changes due to the presence of the atom. So it can be identified. We might have studied in the smaller classes chemistry regarding the nucleus and the orbitals. So here we are going to see, due to the orbitals, the electron usually present in the orbital will have the absorption, that is, for example, radio frequency energy absorbed by due to the supply of the magnetic field to the sample which is kept, can give you the band or give you the graph, give you the result or detection can be seen in the change in their radio frequency energy in the molecule. So when proton, hydrogen is studied, because we can study in the hydrogen, then it can be as PMR, but usually we are telling even proton study also we used to say NMR, nuclear magnetic resonance. So when you study the proton magnetic resonance of a compound, then we can say PMR. When the nuclei is about 13, always odd number. The 12 carbon atom is says 1, that is 13 carbon and 19 F fluorine, 35 chlorine, etc. is studied. Then it is called NMR. Hydrogen also we can say, for example, 1 hydrogen, odd numbers, 1 hydrogen, then we can say PMR and others, but usually both of them are called as NMR. Generally in practice the study of hydrogen proton itself, it is also called as NMR. So we should know about the KLM orbitals. That is why I just made it. The principle of the quantum number of the molecule is very important. Which gas, the impact to study about the basic principle behind the nuclear magnetic resonance. Any molecule, they have the orbitals of K, L, M, N. K is the nucleus, L, M, N. The principle of quantum number. So you can see the nuclei, that is K, with odd mass number only give NMR spectra. 1 hydrogen, 13 carbon, 19 fluorine, 35 chlorine. These all can give NMR spectra. The interruption that is interpretation with the computer graph can be obtained by means of this NMR spectra can be obtained if the molecules are odd numbers, 1 hydrogen, 13 carbon, 19 fluorine, 35 chlorine, because they are asymmetric charge distribution. Spin quantum number for each nucleus, spin quantum, when you apply the magnetic field, the radio frequency energy applied by the magnetic field to the molecule, such molecule half, 3 by 2, 5 by 2, etc. For 1 hydrogen, it is half. Therefore, you can see the orbital. For the hydrogen, we can say 2L plus 1. That means 2L, that orbital, plus 1 orientation. Only this odd number or asymmetric charge distribution can be spectrum of NMR. Change in the spin of the quantum number can be observed. So other nuclei like 12 carbon, 16 oxygen, 32 sulfur, 14 nitrogen, etc. do not give NMR spectra because of symmetrical charge. They are symmetrical charge, neutral symmetrical charge distribution, and their spin quantum number is an integral value. They are even value, integral value, a final value, integral value. So the odd number of proton, carbon, fluorine, chlorine, even nitrogen can also be determined. NMR records the difference in the magnetic property of the various magnetic nucleus present. Okay? And presence of different kinds of environment in the molecule can also be identified. Nearby, what type of molecule is there? Hydrogen, whether it is CH3 in a ring structure or whether it is an aliphatic, aromatic, or it contain any type of other atoms present in them can also be identified by the NMR spectra. There will be a spin change. So when you are studying NMR spectrum in detail, there will be, when you apply a magnetic field, the electromagnetic radiation or electromagnetic electromagnetism or radio frequency, not radio frequency generated by the atom will differ and change, and it may be shifted, that is, you might have the chemical shifting will comes here, and also shielding, de-shielding will occur here. So the delta value which we compare with the tetramethylsilane, I am not going in detail. If I go on detail about the principle behind NMR, it will become a very lengthy subject, but still, at least you should know that tetramethylsilane is a standard item which has 4 methyl group in a silane, which has the clouding of, it has a base of highest delta value, and from that we can identify how the frequency, how the radio frequency changes due to the magnetic application to the samples can be identified. So that will give a very good spectrum in the NMR, which can easily identify what type of proton is there, what type of carbon is there, whether it is in double bond system or it is in triple bond system or in a ring structure or in an open chain or an aliphatic, or whether it is having the functional group of OH group or aldehyde group, which you have identified in NMR, can be justified and can be compared with the NMR, and you can conclude. So all these instruments are having interrelated to confirm your structure. Elucidation of structure of the compound can be done by means of all the instruments what we have studied now. That's what, this is an important chapter which makes the student to have an interest towards and research of isolated compound from a natural substance or a natural plant, and then how to characterize them by means of this instrument. This gives the interesting of the part of the research, or to identify something which we have done. So presence of different kinds of environment of the molecule can be identified by NMR. Which atom is present in the neighbor can also be identified because of change in the radio frequency. So radio frequency applied, radio frequency transmitted. So two things will appear in the NMR instrument. This basic thing students should know. So when I go to the picture, I will show radio frequency transmission, radio frequency detection, or radio frequency which is detected, radio frequency which is applied. So this time you should know that the basic thing, we are giving application of radio frequency or an ampere or an applied frequency is given by means of magnetic field. So the change in the radio frequency in the molecule by means of spinning of the molecules, it will give the environment and the presence of atom and what type of atom is present, a number of atoms, especially number of proton, number of carbon, number of nitrogen, number of chlorine, number of fluorine can also be identified by means of this NMR, which will give the change in the radio frequency, which can be detected by means of our detector. And which atom is present of the neighbor, the group can also be identified. Presence of number of atom can be identified. See this instrument which I told, and that's why that will give you some information for the pharmacognosy students to write about the basic principle of NMR. You see, this is a picture which is drawn by me, especially by means of, you can see in between, you can see the sample is kept. I have not drawn properly. It is a sample probe where you can inject or where we can keep as a solution, or usually made into an sampling is also a biggest work in NMR. It's not easy what I am saying, simply keeping the sample. And anyhow, we just imagine that this sample is kept there and we are keeping RF transmitter. That means RF, that means radio frequency transmitted to the sample by means of keeping the magnetic field. And this frequency is also known frequency you are giving. And then this known frequency, due to the known frequency, usually 90, 80, there are certain frequencies given for individual samples which you are going to analyze. Like whether you want to analyze proton, or whether you want to analyze carbon, or whether you want to analyze nitrogen, or you want to analyze chlorine, fluorine. According to that, the frequency should be supplied, the radio frequency transmitter. And then you can see there is RF receiver. The change in the molecule. The molecule can have a chemical shift, can have a, you can see the de-shielding, shielding, these all words will be occurring. And because there will be some even limitations, all these things, NOE, and there are many terms are there which we'll be studying in detail in your analytical chemistry or in instrument analysis. I am not going into that detail. But anyhow, this transmitted, or after this radio frequency which you applied, and there will be a new radio frequency, change in the radio frequency will be produced by the sample which you have kept according to the presence of number of atoms which you are interested to detect. That will give you the impulse, and that can be detected and recorded, and the impulse can be get as a spectrum. Now we will talk about what type of spectrum. Graph, like we have seen many graphs are very different, and also for mass spectroscope the spectrometry different, and even for UV spectrophotometer is different. So here also we should know what type of graphical appearance will there and how to calculate, how to find out. I have taken an example. Here I have taken a small example to give you an explanation. That time you will understand. So NMR records the difference in the magnetic properties of various magnetic nucleus present, which you have applied and you changed. And presence of different kinds of environment in the molecule can be identified. So which atom is present in the neighbor group can be identified. Presence of number of carbon atom, number of hydrogen, number of nitrogen, number of chlorine, number of fluorine, that number of atom can also be identified. Example, proton NMR spectrum of toluene, C6H5CH3. So there are different types of CH atoms. Aliphatic is there, aromatic is the CH3 separate, there is toluene, C6H5 is benzene aromatic. So you see, the peak you will get, this is a peak also drawn by me just and by means of paint I just drawn, maybe it's an imaginary, it's not an original, but anyhow you will get two types of peaks. So a long peak which shows that 5 ring protons are there because CH5 in benzene, so 5, and you can see that CH3 is outside. If you see the structure of toluene, C6H5CH3. So that CH3 is outside, it is aliphatic CH3. So methyl proton, it has a small peak. So these type of peaks will give you the height of the peak and the width of the peak and the length of the peak, which gives the number of hydrogen present also, number of atoms present also can be identified. See that 5 ring peak and the position where it is getting, like x-axis, y-axis, you will get the transformed radio frequency versus the energy. You will get automatically the concentration, the delta will be in the x-axis, so that you can compare this one with the, as I told, there is a molecule which has 4 methyl group in silane. Tetramethylsilane is the one compound which is used as a standard for identifying various protons, and even why not, even for carbon. So that is one example, and this is another example I have told you, that is I have taken to show you OH. See, presence of other atoms, presence of the environment in the proton or in the nearest ring also can be identified by NMR. You see this graph? See, this is benzene ring proton, you can see the peaks here. A singlet, quarterlet, triplet. What is this triplet? Quarterlet, singlet. Singlet means one peak. Quarterlet means one big and another 4. Triplet means one is middle and 3. So you can see there is CH3, CH2, quartet. Why it is quartet? Because CH2 is there. It is attached with one double bond of the ring structure. So quartet type of CH3 is there, CH2 is there, and also triplet type of CH3 is there. And OH is singlet. O is separately, that is functional group. So when you are getting a peak in the IR spectrum in suppose 3150 or 3050, a peak, very sharp peak, then you can say there is OH group is present, and also you can see there is a singlet which is obtained from the NMR. So that is the confirmation. So one instrument by means of getting the spectrum, we cannot confirm for the structural elucidation. This what all the instrument which we are studied for elucidation of a structure, it is needed for you to comparison. This I am just sharing my small knowledge which I have. There are many experts are there, how they will interpret. Scholars, research scholars, they are many are there. You should go and talk. I am giving you basic knowledge for the degree level. But if you see in the research level, they can interpret what is the graphical or the spectrum brought from NMR, IR and UV and also mass spectrum. They will compare and they will finalize the structure. So this gives, I want to give an idea for the student. So this is only an idea, basic knowledge. What is the application of the instrument in the structural elucidation of the compound? So here the graph, you see the graphical appearance example. And this is the original graph. To just to show you, see here, ppm, parts per million of the concentration in the delta, and here the or you can see the radio frequency produced, frequency Z by E, it is the value which is given there, which gives you, see, the quintet, quartet, singlet, doublet and triplet type of peaks are there. So one is methyl aliphatic amide, nitrogen present in the hydrogen, carbon CH type of methyl group, that is aliphatic, and the side chain NH, aromatic CH. So these all can be identified. Only I am just showing you the picture and just telling. Even I don't know how to I just, frankly speaking, I am not very much expert to interpret. Interpretation can be done by means of big scholars, big the researchers who are big professors who are working in the research area. They can interpret, but we have to discuss with them. The experience will make you to conclude by means of all the spectrum which you are taken from different instruments. And now we are going to explain. Now you might have got some idea about NMR spectra. And here, what is the RF transmitter in the picture I told? RF, that is radio frequency transmitter, which is used to apply radio frequency of 60 megahertz, 90 megahertz, 100 megahertz, 220 megahertz, 400 megahertz, depending upon the capacity solution of the instrument. And then after applying the magnetic field to the sample, and the produced reaction radio frequency which is done by the atom can be transmitted to the detector, their receiver. So to measure this radio frequency receiver is to measure the intensity of unabsorbed radio frequency energy. There will be another part also in the picture in the instrument, that is sweep generator, to vary the strength of applied magnetic field which you are applying to sweep magnetic field. A field strength usually given is 14,092 Gauss or 21,140 Gauss or 23,490 Gauss, etc. It is used depending upon the frequency region at. So usually 1 tela is equal to 10 to the power of 4 Gauss. So if you are telling 14,092 means 1.4092 tela. Understand? Tela is the count of the field strength in the magnetic field. So you should know what is the unit which they are using for applying magnetic field. Most instrument currently used in the proton study operates in 60 megahertz, that is 1.4092 tela. That means you can see 14,092 of Gauss. And you can see 90 megahertz, that is which we are told about 21,400 Gauss. And 100 megahertz, that is 2.349 tela. But in Gauss, if you can see 23,490 Gauss. And recorder, you can see computer, the record of NMR signal obtained from the detector can be recorded. Sample cell is also plays a major role, which is in the picture which I showed as tube, which is of 25 centimeter and 5 millimeter outer diameter kept inside the sample cavity, and a spun, it will have a spin of rotation of 30 revolution per second, that is RPS, and as also provide uniform magnetic field to the sample of the solution, and then the radio frequency produced from the sample can be received by the detector. I hope students will be more interested to know about this principle. There are many things to be known. As I told, shielding, de-shielding, NOE, there are many complicated system like moving, what is the radio frequency changes in the molecule, how it happens, and what is the tela means what is the sample, what is the trimethylsilane, how it is applicable for identifying these all things comes in the instrumental analysis. We are just coming to the application now. We have finished the principal part of the NMR. Now we are coming to the application of the NMR. The structural elucidation of natural or organic compounds obtained. Isolated compound, organic compound, invariable, have hydrogen atoms in their structure, and environment of such proton is not the same. Hence, the NMR, nuclear magnetic resonance spectra, following can be known about the structure. Types of proton, environment of the proton, number of proton in each type, number of adjacent proton can be find out whether it is a methyl group or it is an aromatic or aliphatic, open chain or with a double bond or a triple bond. These all proton types can be identified. And investigational of dynamic properties of molecular like conformational isomerism. You know isomerism, there is isomerism, optical isomerism, geometrical isomerism, you have many types of isomerism. So these isomers, they have same chemical formula but only the position isomers or optical isomers, or there will be the board shape, chair shape, like that you can have many type of geometrical isomers. So molecular asymmetric, hydro bonding, keto, that is enol tautomerism. Enol tautomerism means like you have enolic form. The OH group can also be formed into keto group, like how ascorbic acid have an enolic structure or tartaric acid have an enolic structure. So enol tautomerism can also be studied in this form, can be done by NMR. What is the position, how many hydrogen is present and what type of hydrogen is present, in what form it is present can also be. Determination of optical purity is also possible. Study of molecular interaction like mesyl formation, mesyl network formation, which is more useful for the formulation system. Mesyl formation and drug macromolecular structures or drug receptor interactions can also be studied in this. Quantitative analysis also can be done. Assay of component and surfactant change length determination in surfactants which you are using in various liquid oral preparations in the formulation can also be studied by NMR. So now the very important chapter which this is also the next, that is instrument, which is electrophoresis. Apart from the even like chromatographic technique, this electrophoresis is also one technique which can be isolation of compound. DNA electrophoresis, gel electrophoresis is also very important. DNA fingerprinting, these all are very important techniques which is nowadays available. There are capillary electrophoresis, and this is very important. Next class we will have a discussion about this. Thank you.